Friends, welcome to Data Discovery. Over here, in this channel, we are going to learn something more relevant part related to a data science part, data analysis, all the AI tools related to Python, etc. techniques that we are going to learn. So today's video it's related to a feature engineering. So in the part of the feature engineering, feature is nothing but the columns. Okay, in the layman way, we used to say as a columns in which in the data we used to have several number of columns and the rows. So the data is made up of rows and columns, right? So based on that, we used to do a feature engineering techniques like feature selection, feature extraction, encoding techniques, outliers detection. So all the part are included in the features. So one of the part that is called as a feature selection that we are going to see at this video. Why the feature selection plays an important crucial role, and without using a feature selection, if I'm building an algorithm based on it, what all are disadvantages are present and how we can overcome it, etc. things that we are going to discuss at this video. So let's get started. Now we'll just make a small recap of the data rows and columns. Then after we will be starting to do feature selection techniques, etc. things. So in the data, we used to have a row. Okay, infinite rows, more number of rows will give a good accuracy that we can say, so more information we can gather. The same thing with the help of the more column, also we can get the good accuracy, etc. things. But if we are adding more number of columns which is not relevant to the algorithm that we are using, like if we need to predict the weight of the people, so what all features that I will be adding, like age I need to have, height of the people, etc. things that I will be having it so that I can predict the weight. But if there is a information which is related to a blood group, okay, or something related to an address of the people, mail id, phone number, so because of that I couldn't able to predict that what will be the weight, because this is not a relevant features. So by using a domain knowledge we can easily identify that this all are the features which is not interested. But if I'm not a domain expertise, that I'm not aware that what are features that I need to have to predict it, so at that moment we need to use some of the techniques. So related to that only, we are going to discuss at this video. So first one will be to reduce the dimensionality of the feature space. So more number of features, then dimensionality also increase. So features increase, even the dimensionality increase. So if the dimensionality part is increasing while doing the model training, okay, it will take a lots and lots and time to train the model. So for that we need to reduce the features. So if the features is important, okay, it's relevant to the target variable, then definitely we need to use it. But if the features that we are using it's not at all relevant, then we can remove it. That as I have said the examples related to that, I need to predict the weight of the person. So for that the blood group, address, phone number, etc. things are not at all important. So at that moment I can easily cancel it out, I can easily remove, I can easily extract the features, the particular features that which are not at all relevant to the target variable. Okay, target variable it's nothing like what usually I used to say the target variable, right? So target is nothing but y that we need to predict. Okay, that we need to predict or detect, etc. things that we can say it about it. And x is nothing but a feature. Feature is nothing but x. So we used to mention this x and y. So if x increase or y decrease, or x increase that even y increases, so based on that we used to plot it. So this is not x is nothing but the features. So we used to have lots of number of features like x1, x2, x3, we have lots of number of features and one target variable. So based on these features we need to predict this y. Okay, so if this x1 is used in this y, then we will be taking this x1 as a feature. But if this x2 is not at all relevant to y, then we will be extracting this data, extracting this x2 from this data. So based on that the extraction part is used in the feature selection. Second disadvantages without using a feature selection is to speed up the learning algorithm. So as I have said, less number of features, Okay, less number of features, in place of that word we can use the relevant features. Okay, if we are using only the relevant features that we need to predict or we need to identify it, then our algorithm speed will be increasing. So this is the another major disadvantages without using a feature selection. Okay, so the third point is like improve the predictive accuracy of the classification algorithm. Okay, so I'll take one data. So same data having a lots number of rows and column. Okay, in this data I'm having only 8 rows. Okay, I'm having 8 rows, sorry, 8 columns. I'm having 8 columns and infinite rows. The row will be same for both the condition. Okay, if this is thousand, if I'm having in the A data having 1,000 row, even on my B data also I'm having the 1,000 row, but the column size is decreased. Like I can give only 5 columns. Okay, by using a feature selection technique I have reduced the feature which are relevant to the target variable, and I have reduced around 3 features, so 3 columns. So that's what I'm having around 5 columns. So over here it will be the dimensionality will be 1,000 into 8, and over here 1,000 into 5, right? So by having this dimensionality we can easily say that it reduces the dimensionality of space. Like by using a feature selection technique I have reduced the features. So my first condition true, and even if I am having a less number of columns, even the speed will be reduced than the my first data, A data. So even the second condition also passed. So the third condition what it says like, if I'm having a less number of columns my accuracy also will be improved. Like here around 8 columns that I'm having, as by using a feature selection technique I have reduced to 5. So by using 8 columns which are not relevant, like around the 3 columns which are not relevant to the prediction, so because of that my accuracy might decrease than this. Like by using my part A data I'm getting around 80.91 percentage. Okay, uh, but I'm having the dimensionality of feature spaces is increased at the part A, and even my speed of the algorithm it also takes place more number of time it takes place for the my part A, but my part B has passed the first two criteria. And if I will be calculating the accuracy, then I might be getting more than this, like around 82.41. Okay, 82.41. We couldn't able to say that it has the good accuracy or something related to it that we will be coming across. Like if I'm having a 90% accuracy, it's nothing, it's we couldn't able to say that my model is best. Okay, for that also we will be having a criteria like training and testing data. So the trained data and the test data should match, so then only we can say that the accuracy will be good. So anyways we will be coming across later to a good accuracy, bad accuracy, etc things, but in this I'm just giving the examples that how much accuracy that I'm getting. Okay, by using a part A I'm getting 80.91, over here 82.4. So there is not a much difference between it. Okay, that is not much difference, it's having a difference but that is not much difference. So by using a lots and lots columns, and if I'm increasing the dimensionality and the speed time is also increased, so that from that also I'm getting around 80 percentage only. But with the using the feature selection technique, okay, I can improve only 2 percentage, but still that's an improvement. And the speed of the learning algorithm by while training the algorithm also it reduce. So feature selection it's one of the way, it's one way, it's not the only way. So by using it I have just improved it. So this is the proven that by using a feature selection technique you will be getting an improved accuracy. Anyways I will be showing this example, I have prepared a notebook for it in which you can see that without using a feature selection what's the accuracy, and with using a feature selection what's the accuracy, and how it improved it. So based on that we will be using a technique and we will be seeing the improvement percentages also. The fourth major disadvantages is like to avoid overfitting. Okay, I'll take a small example with the decision tree because you can able to understand it very easily. Now you're having a same data. Okay, we'll take the part A data itself. Okay, so it's just I'm giving a examples related data. So once I am selecting the features, okay, then after in the decision tree or random forest you will be getting a branches, and then after the again there will be a certain threshold condition in which like I'm selecting a height based on it. Okay, I'm selecting a height. So if it is greater than 185 point something centimeter, then over here. And if around, if it is less than, then greater than one side and less than one side, so based on that we will be creating a branches more and more. So these branches are increased not because of the row is the one condition, but even because of the column. Okay, so more number of column, overfitting values will be greater. So if your model is a type of the overfitting, it means the model is mugging up all the thing, all the data it's mugging up, then your accuracy will be improved, but that's not a good model. So while training you will be getting accuracy around 90 percentage, but while testing you will get around 60 percentage. This is because of overfitting. So this is the major disadvantages. Without using a feature selection technique, it avoid to overfitting. So this is the another condition in which feature selection technique comes into a picture. So there are several feature selection techniques, so one by one we will be discussing it, and we will be seeing the difference between without using a feature selection, what's the accuracy or what's the difference that we got it, and by using a feature selection, what's the difference that we are getting it. So first technique that we are getting started with it, it's called as a filter method. Okay, in this filter method you will be getting a two branches. Okay, there will be two branches. One will be a Pearson correlation. Okay, it's one of the statistical method, and next will be the mutual information. Okay, so let's get started with it. So Pearson correlation, it's nothing but it measures the linear correlation from each features and the target variable. Features with high correlation value are more likely to be relevant. Okay, and mutual information, it's nothing but MI, is measures the amount of the information shared between the features and the target variable. Higher mutual information indices will be more relevant. It's the same example that I will be giving. So you will be having a data in which you're having almost 11 columns that you can say. 10 columns is your feature value, so 10 it's nothing but your feature, that is nothing but x, and 1 will be your target variable, and that will be your y. Okay, so from each and every features you need to compare with your target variable, and you will be plotting a graph. So this is will be your x, that is a feature, and the target variable. So this is my x1. Okay, and you will be plotting it. So if your plot in this format, then you can easily say that, so my x and y it's correlated. If my x increase, even my y also increases. Okay, and let's take the other feature. Okay, taking as x2, and over here same y target variable. In this you can see that if my x increase, my y decrease, in which x2 and y is correlated. So this is the type of the correlation method. Okay, it's one of the statistical method of the Pearson correlation, in which you can identify that what's the relation between x and y. So the another x3 we will be taking. X3 is nothing but my third feature and my y. Okay, we are just comparing the features with the target, each and every feature that you need to compare. So over here you can see like this. So there is not any relation between x3 and y. So if my x3 increase or not, it doesn't matters with y. So it's not dependent, in which we can say that this feature is not relevant to y. Okay, so based on that, the filter method is used. We will be seeing the coding, and which I will be importing one sample data by using the sklearn library. Okay, you can take any of the data that you are having and just do the steps as I have done it over here. So as I have said that in which values lies between -1 to 1. Okay, if my x increase and my y also increase, then you will be getting the value as +1. If my x increase and my y decrease, then you will be getting a close value related to -1. So this is how the PSM correlation or mutual information is calculated. So based on that, you can identify this feature is relevant to my target variable or not. So I have, as I've said, I have created one sample data, okay, in which I have imported from SK library. But if you are having some other data and you like to import this feature selection techniques in your data, then also you can get my notebook in the description box. Is my GitHub link, okay, in which you can go through it and you can check with the code whether it's working, and how it's working. Just mention the comment and you will be getting more and more techniques. So which technique that you need to use it, you need to take care of that part also. So based on the problem statement and based on the data that you're having, the feature selection technique varies, so that you need to see it with it. Okay, first I have just imported all the necessary things that we need to have, like numpy, pandas, matplotlib to plot it, and to see all the data frames, and you need to do something related to the operation related to data. You need to import the pandas, and to array conversion, 2D, 3D, etc. things that you need to have a numpy in your hand. And next, all the feature selection technique like select kbase in the SK library, it's an inbuilt ones, and mutual information classify. Okay, it's all the inbuilt one that you are having it over here. I have imported my data in which x and y I have separated. X is nothing but my feature variables, and y is nothing but my target variable. Okay, so you need to guess it, like my feature variable will be more than my target variable, right? It's nothing but my feature column. Feature is my column and my target is my column. So target that you will be targeting in one column, but for the targeting you will be having lots number of feature. So that's why my x value, the x variable, will be large than my target. I hope you got it, because you need to know between the column that what is the feature variable and what is the target variable. So whenever you are dealing with the data, most number of the website that you will be getting this type of the word, like a feature variable, target variable. So you should not be able to confuse that feature is a column. So why they are segregating between feature variable and target. So I hope you got it. Next, you need to know that I'm just selecting my data, my top 10 features that I need to have. So in the data itself, there is lots number of features, there is not lots number of column, in which I need to have only 10 top feature. Okay, so how I will be calculating, I will be calculating based on the score. So if my values lies close to +1 or lies close to -1, that feature I will be more interested on it. So rather than lying in the circle of 0, I need to have the close variable related to +1 or -1. So what you can do by using the selector, okay, in which you will be giving the input of mutual information classify and k is nothing but how many features that you need to have. So based on that, you can calculate the score, and you can print the score, and you can see that you can keep a threshold by using by getting the information from the domain expertise, that after what value I can select. So as per the data and as per the domain that you're working, if the domain expertise say that use the feature if it is greater than 0.8, then you need to select that only features. Okay, so I have selected your top 10, but according to you, according to your domain that you're working, ask your domain expertise that what need to be the score of the feature. Okay, and over here I have just plotted this, all the plotter techniques, in which I have given the x label, y label, title, what title that I need to have it. And over here I have short the values is nothing but in the ascending order. So higher the value, it need to print in the first manner. So based on that, I have sorted the in the ascending is equal to false. Okay, and then after you will be getting the plot and the um score. This is not the score value, this is not this is the feature value. So this is my first column, and most important is most relevant to the target variable. My second column is the most relevant, third, sixth column. So based on that, it's just giving me the thing. So this what you need to, this is how we will be using this feature selection technique. So by using a filter method that I have done it, you just input this code in your project. So if you're not understanding this part, like what will be the score, how you're calculating the score, then it's an inbuilt one. Okay, and then after that, I have said that by using that, you can even the print the score. So for the worst perimeter, the score is 0.4, and for worst area, it's 11 to 0.4, around 0.46. So it's able to input in the decreasing order that you can see it over here. So if the domain expertise say that you need to select the feature if it is greater than 0.4, then you will be selecting this wall one, from this to this. Okay, and only this to this. Okay, over here you can see it is less than 0.4, so these are not the relevant features, even you can skip it out. So based on the domain expertise and based on the work that you are doing and the data that you're working on it, so the value differs. The next technique that is called as a chi-square test. Okay, it's one of the hypothesis testing technique. Okay, in which in the hypothesis testing you used to have the z test, t test. Okay, so in which this chi-square test is also used in the feature selection. So first we will see the formula related to it. Okay, what's the formula? Based on that, you will be getting a relation between the feature selection why we are using and what's the formula. So the formula is the summation of observed minus expected square divided by expected. So you can see it in this way, like the observed and the predicted. Okay, so the observed is you're predicting the weight around 25. Okay, but the expected, okay, the observed and predicted, and but you have predicted is around 25.1, 25.1. Okay, the difference is very less, zero point 0.1 only. So your observed and expected is quite close to each other. Okay, then two features is independent. If the observed count is close to the expected count, the value will be smaller, right? So higher the value gives the feature importance more. So if your observed is 25 and your expected is 30, 25 and 30, the difference is 5. So higher the values gives the feature importance. So I couldn't able to say that 25 and 30 gives the higher value if the difference is quite more. Comparative to my first condition, zero point 0.1 difference, 5 is more, right? 5 is more than zero point 0.1. So based on that, the feature is important. We couldn't able to predict that if it is greater than 5, then feature importance will be more. So based on the data that you're dealing with, the feature importance will be different, right? So as compared to my first part, that while I am differencing the part like 25.1 minus 25, that at that moment I got the difference as 0.1. And while I was differencing the part like 30 minus 25, at that moment I got as 5. So at that moment my feature importance will be more on that the second part than my first. So higher the value gives the feature importance more. So based on that we will be doing it. So as I have said that first we need to import the libraries. Over here I have imported one of the data set which is inbuilt from the SQL in itself. Okay, in which I have taken the feature variable and target variable. And as I have said that I am taking the k value that I'm going to select. K is nothing but inbuilt, but I am giving the other name is called number of features to select. So I'm giving as 10, in which I'm fitting the transform into my feature selection part so that I can get the score. So if you will if you will print this print the selected features in the indices, you will be getting the indices. You can if see the scores related to it. So for which features what score it denoted by using the chi-square test. Okay, and the another important thing that I need to say that the score that you're printing in chi-square test and by using a filter method will be different. It will be not same, because you're using some different method in chi-square test, and different formula, different method in the filter method. So the score differs. So based on the data and based on the domain that you're having, you need to select that which feature selection technique that you need to use it. Okay, so over here I got some of the indices, that for zeroth column is important, second column is important, third column is important for my target variable. So this is the another method. So the third method that we are going about L1 regularization. It's one of the regularization technique. Okay, we used to call it as lasso. Okay, this is a regularization technique while solving a regression problem statement. Because why it comes into a picture that we will be seeing more when we are doing the regularization techniques like L1, L2, ridge lasso, something related to it. But I'll give a small thing that how you need to understand it. Okay, regularization technique, it came to picture because of overfitting. Why overfitting? Because what's meaning of first of all overfitting? Overfitting, just I'll be saying some small part related to overfitting. Okay, here you are having a training data, you are having a training data set, and here you are having a testing data set. Okay, first you need to train the data by using the 80 to 20 rule, or 80 75 25, it's up to you. And by using a training data you are getting accuracy around 90 percentage, and by using a testing you got around 75. Okay, you will say that if I'm getting a accuracy around 90, then my model is best, then this model is the best, right? But it's actually not. While doing a testing you're almost 15 percentage less, it's a more depth in which your model is not at all good. See, if it's performed well in training and if it's not performed well in testing, then your data will be looking in this format, like I'll be presenting in a wide moment. Okay, this is a data point that you're plotting. And while, okay, now I need to fill a best fit line. Same thing I will be presenting over here. So if I need to present a best fit line, then the actual and predictor should be less, so based on that I will be printing. But while doing this type of the data, like 90 and 75, so at that moment if you will plot it, it will be like this. It will try to learn each data, and you will get a line like that. Because of that your training will be good, but while testing the line will be like this. For that purpose it's 75. Okay, so which leads to a overfitting. So at that moment you will be applying a regularization technique, lasso technique, in which it reduces the overfitting part. Because of that, because it adds one of the penalty term lambda in that. Because of that lambda, you will be not mugging up each and everything, you will be giving a best fit line. So from this data, by using a regularization technique, you will be getting this type of the plot. Okay, this is some quite idea related to regularization technique. We will be learning more when we are learning about regularization, but how this is important in the feature selection, that we will be seeing. So while learning about feature selection, I have important one fourth point. It leads to a overfitting that I have said. So for overfitting, this is the example, and for avoiding it, we are using this regularization technique. So it's one of the shrinkage technique. Okay, will be learning about it. So I'll just read to one of the technique. So what it happens, like, it will take a iterate part. Iterate is a iteration. First iteration, second iteration, third iteration, it will take a iteration. Iteration is like you can able to control it, how much iteration that you need to have. So when we are taking an iteration, so at that moment the lambda value will be updated. So once my line close to the best fit line, so it will by updating the lambda value, the line that you are printing, it will come close to the best fit line, in which my actual and predicted will be 0, will be less than value, will be having a less value. Okay, so lasso tends to force some of the coefficient to exactly 0. Exactly 0 means the feature which is not important, it will tends to 0, in which we can identify that all features is not at all important. So that's bringing, because of this lambda part, because of this lambda, you are getting the feature which is not important, so it will be 10 to 0. So while tending to 0, that feature from your feature variable will be extracted. So this is one of the feature selection technique that we'll be using it. So over here, I have imported one of the data only from the sk library, in which I have given alpha is nothing but lambda in our case. Okay, alpha you can say, or lambda, over here in the lasso cv itself, they are given the input as alphas, so you need to not confuse with the alphas and lambda. Alphas and lambda is same. Okay, in which the lambda value that I'm giving, it's not an inbuilt that you need to give some of the values, like, so I have just given by using the array of the log space minus 6 comma 2 comma 100. Okay, you can give any value, so based on that, at every iteration it will update it. And if it is tending to 0, okay, if it tends to 0, then the coefficient which is not relevant to the target variable, that only will be tending to 0. So then we can easily identify that this features is not at all important, and based on that you will be getting the features. Okay, so over here you got which all part, which all column that is in, which is important for the target variable, column number and the score. Okay, so this all are the scores. This is 79 percentage, is important, it's nothing but it's most relevant to the target variable. You have 15 percentage, you have 54. Okay, 45 here, actually I have presented top 10 I think, so because of that it's giving her 10 values. So what value that you need to have, so based on that, if you will be giving a condition like you need to have more than 80 percentage, so based on that it will be printing out. This is the fourth part that I need to say in between my feature selection also. So most of the people used to think that PCA is a part of a feature selection. So I like to identify that feature selection is different, feature extraction is different, and PCA doesn't include in feature selection. So principal component analysis, it comes under the feature extraction technique, not a feature selection technique. So we will be seeing the video related to feature extraction in the different video. So before that, do like, share and subscribe to this channel, so that you will be getting update related to feature extraction, and why it's, what is feature extraction, and why PC comes under the feature extraction, that we'll be seeing in the next video. Okay, so don't be confused that PCA will be in the form of feature selection. So feature selection is different and feature extraction. So in the feature extraction, what we will be doing is like, feature extraction is not concerned with the selecting specific features, rather it creates a new feature that are linear combination of the original ones. I'll just give a small picture later to it, so that you can able to understand. Okay, the goal is to represent the data in a lower dimensional space, in which you will be changing the values of the data only. So if you're having a height as 170 centimeter, 180 centimeter that you're having in a feature selection, you're reducing the features whatever relevant to the target variable. But in feature extraction, you're not reducing the feature, you're changing the values of the data itself. So feature selection, feature extraction is quite different. Let's move to the next technique, that is called as a Fisher score. Okay, like previously that we have seen related to Pearson correlation, L1 regularization, that's a inbuilt ones, in which a lasso CV that we have imported. Okay, so based on that, we could able to calculate the score very easily. But in the Fisher score, it's, there is not any inbuilt type of the thing that we can able to find the score very easily. So for that, we need to use this formula, and we need to use this formula in the code also, then only we can able to find it. So how this score is most important in the feature selection, that we are going to see it over here. So higher feature score values, indicates that the mean of the features, like over here that we are calculating mean 1 and mean 2, so indicates that the mean of the feature for different classes are far apart. Okay, if it's having a higher values. Okay, we couldn't able to say that which one is the higher value and which one is the lower value, that we need to compare between each and every features. Okay, based on our features, if one of the features had having a zero point 0.2 and another feature are having a 0.25, then 0.25 will be larger than 0.2. Okay, this is how we need to identify. So based on the data, different higher and different lower values that you will be getting, so you need to compare in that manner. And the variance is nothing but the spread within a data. So more number of spread, based on that we are calculating the Fisher score, in which of variance within each class it's small related to the separation between a means. Okay, this implies that feature is discriminantly can help distinguish between the class. So higher the mean value and lower the variance value will be saying that the feature will be most important. So based on that we are calculating it. So as I have said that this technique, it's not imported ones. We couldn't able to get the feature score in just one line of the code. So for that we need to use this formula and we need to write it. So what I have done it, I have taken a part wise. So first, this is my data, my feature variable, and this is my target variable, in which I have iterated with each and every column my target variable. So this is iris data. I hope remember that it's having a setosa virginica type of the target variables, around the 3 to 4 variable, I hope so. You just go through it, in which I'm iterating with it and I'm calculating a mean for it. So for my first column, this is my mean, my second, my third, my fourth column, and the target variable. So it's saying that around 3 target variable that I'm having. So based on that, I'm getting the mean one. Okay, and in the same way you need to calculate for the variances also. So by after calculating with the mean and variances, what you need to do, you need to use this formula. So that is nothing but mean 1 minus mean 2 raised to square, means square time, divided by variance 1 plus variance 2. So that's what I have done it over here. Okay, we need to do it by iterating through it, and we can calculate the score. So what you will do, you just print each and every part, like for this part what it's saying and what it's doing it over here. Okay, and then after it's all stored in the list format, and that list is used in the score, and then after it's appended on the Fisher score list. Okay, this is how we need to update it. So step by step, if you're not understanding it, you just print it what's happening. Okay, from what happening over here, and then after in X what all things are stored. Okay, in step by step that you need to do it. So as I have done it in some of the notebook that you can see it in my notebook itself, that I will be sharing in the description box. So over here it's printing around all the Fisher score for each and every target variable. So I can see my second column, that whatever that I'm having a less number of score comparatively to other three. So my third and fourth are having a good amount of the score, Fisher score. Okay, so now is the most important correlation coefficient. It's quite related to a Pearson correlation, but there is a difference between a Pearson correlation between this. Okay, that we will be seeing in the statistics class, that what's Pearson correlation, etc. things. But for the feature selection, what we will be seeing, that what value we need. Okay, correlation close to 1. If I'm correlating between my feature variable and target variable, and I'm getting a close to 1 value. Okay, you will be not getting exact 1 or exact minus 1 or exact 0, you will be getting a close to 1. So what it denotes, it indicates a strong positive linear relationship between the two features. As one feature increase, the other tends to increase as well. Okay, feature close to minus 1. Similarly, if it close to minus 1, then one feature increase, the other feature decrease. Okay, it says that it's also it's linearly relationship, but it's negatively linearly relationship. Okay, but if it's a correlation close to 0, it indicates a weak or no linear relationship between the two features. Changes in one feature do not necessarily predict in the other. Okay, so we are expecting that the correlation value, it should be lies between +1, or it should lies between in close to -1. not between, close to plus 1 or close to minus 1. So it's a inbuilt one. We can take the correlation matrix also. Okay, based on that we will be getting a plot in which this how we need to read sepal length and petal width, what's the correlation coefficient, sepal width and petal width, what's the correlation coefficient. So based on that we can identify that which features is most important. So as the value that we need, if it should be greater than 0. 0.8, so this all features that we need to select, this etc things. Okay, the next technique is called as a variance threshold. So first, we need to calculate the variance. Okay, and what is variance that we will be seeing it over here? So compute the variance for each features across all samples in the data set. Then what is the variance? Variance measures how much the value of the features are spread out. Okay, how much the features are far away from the mean. Like that, we need to find. Like that, how we will be finding out. Features with low variance have values that don't vary much from samples. Okay, so this is how we will be calculating the variance, but we need to give one threshold. So computed threshold value for minimum acceptable variance. Features with variance below their threshold are considered as a low variance features, which is not at all important. Remove features with variance below the threshold. So if the variance that vary the threshold that you are giving it's above it, then just accept the features because it's important for the feature selection part. Okay, this low variance features are considered less informative and might reduce noise to the model. Okay, so in this variance threshold, by that we can find the values of variance and we have given the threshold. So you're keeping a threshold value as 0. 0.8. Okay, this you can hyperparameter tune, you can tune yourself and you can get the value the feature as per your need. Okay, I'm just finding the variance between the features and then after I'm keeping a threshold. So if it is more than this at that part, all the features it will be giving me. Okay, now next technique is called as a measure mean absolute difference. Okay, it's in the regression side. Okay, we used to have for calculating the actual minus predicted and what's the difference and what's the error. To find the difference we used to have the MSE and the MAD part of the thing. There is more part. MSE is called as a mean squared error, and MAD column mean absolute difference. So MAD is also used for the feature selection part. Okay, these are techniques that we have, but you can, as per the data that we are having, the techniques that we need to use, the threshold that we are setting, it will be differ. So that's a type of the hyperparameter tool that we need to do, and we couldn't able to predict that by using every technique within the same data we will be getting the same result. So the threshold that we are keeping for each and every technique that we have seen, so it differs as per our need. Okay, so just see that what techniques that you need to use for which feature selection part and what the threshold that you need to keep. So this we need to take care of it. Anyways, we know the method, but still in MAD, we know that as a summation of xi minus mu my n. Xi is nothing but the data point, mu is nothing but mean, and n is nothing but sample, how many samples that you're taking. Okay. It provides the measures of the variability or dispersion of the data point around the mean. Measures with higher MAD have greater variability around the mean. It considered as most relevant and informative. So here we are calculating the MAD of it. We are finding the absolute value and we are doing the argument short for it, in which it calculates the in the ascending order. So in which it calculates, like previously we have calculated the indices for it. Now by using the indices we have calculated the feature name. So this is just the coding part. If you're not understanding with any part, just take the step by step, print it out. Okay, step by step, print it out. Like what I'm doing over here. Like over here, I'm calculating the median for it. Then after absolute value, and then after mean. Mean by what? Absolute difference, in which axis is equal to 0, in which I'm taking the row. Okay, this is how we need to do it. Next one is tree based. Okay, it's a tree. In the tree based technique, we actually in the decision tree we used to have the Gini and entropy based. So what it's actually doing, by using impurity score, okay, like Gini entropy and many more technique, it calculated and finding out the feature importance. So it's calculating the impurity score, based on it we are finding the feature selection. Okay, so it's an input one, like we used to have the clf.fit. It's an input one, so here we are not using any of the um, calculate. If we are not doing like for variance, that all things that we have calculated the part, right? But over here it's all inbuilt ones, in which the random forest itself has the feature selection part. So whenever we are dealing with the data, in which whenever we are building the algorithm, so before starting with the training, testing, etc. thing, we used to do the feature selection, feature engineering part need to be clear, right? But while we are doing with the decision tree and random forest, the decision tree and random forest inbuilt has the to do the feature selection part. So while we are decided to do only with decision tree, so at that moment we can use this technique. Okay, it's a having an inbuilt. So after completing with the feature selection itself, you can start with the training, testing, and finding the accuracy, etc. things. Okay, so over here it gives the feature importance, which feature is most important, and it's giving the score value. So and it's calculating the argument shot, that is in a descending or ascending order. So it's nothing but the higher value it's giving in priority, like 0.4361 is the highest than the other. So, so petal width and petal length has the good amount of score, so these features are selected. Okay, if you're not understanding, just try it with line by line. So what the first line is doing, what the second line is doing, etc. Okay, and then after knn, so what's this knn? Knn is one of the regression algorithm. Okay, it's a okay, it's a in ml, it's one of the regression algorithms. So what actually do, like, we are having one I will be explaining with the plot only. It's very interesting. So I'll take only two group. It's a regression algorithm, and so we are having a two cluster group. Okay, for example, now I'm having one data. This is one data. So what we will be doing, it's like whether this data, the data point, it lies over here or over here, that how we can find it. So what we will be doing, we will be calculating the distance for each and everything, like for each and every data point we need to calculate the distance. So minimum distance whatever it follows, and it follows continuously. Okay, we will be seeing the percentage, that how much the data point that lying over here or here. So based on that it will be distributed, like if there is any outlier, or if there is any missing values. Okay, we are having a data in which uh, in one of my column two values are missing. So what we will be doing, so we will be calculating some by using a cane, and we can do it. So we used to calculate the distance between it, and we will be imputing some of the values. So by using a mean, median, and mode, we can impute the um, we can impute the missing values. In the same manner, by using a cane, and also is also used for the sorry, it's also used for the unknown values, that for imputing it. But the same thing, even it's used for the feature selection. So how it's used, so let's see it. Okay, KNN measures the feature importance based on how often a feature is chosen in top K members. Okay, top K, in which K is a hyperparameter tune. Okay, in that we need to select feature that is consistently at top K neighbors across many point might be considered more informative and important. Okay, k is a hyperparameter tune, as I said, so you need to impute that k as per our need. Okay, so based on that, we will be getting the good amount of features, and it need to be continuously in the iteration format. So again and again that features is coming in the top 10 something like, so that features will be most important. So based on that, I have calculated the accuracy with all features. So I have imputed one data in which I have found the accuracy over here. Okay, and then after this is nothing but creating a model for features. So when I was doing it, I got around 68 percentage. And then after, by using a KNN, okay, by using a KNN feature selection method, after I done with it, I got around 76 percentage. Okay, so you can see the difference. So anyways, by using the around 3 columns was there, accuracy with all features, but accuracy with using a feature selection, it's around 76%, but over here only 3 columns, so 4 columns are reduced to 3 columns, and accuracy also improved. So as I've said, the accuracy will be also improved by using a feature selection, so this is the proof for it. And it happens for each and every techniques. Okay, it happens for each and every techniques, and whenever you're doing it, so definitely it happens at least 1%, it will be increasing. So you just check with it. So feature engineering part plays an important crucial role. So as this video have came across the feature selection, so next video will be related to feature extraction, more about outlier, how you need to identify it and how you need to impute it, missing values, etc., things that we will be coming across it. And the question, it's like feature selection techniques in ML and DL, how to deal with it. Okay, so in ML and DL, the difference that we need to understand, like ML can also able to solve the regression classification type of the problem, even the DL also can able to solve the regression classification problem. Okay, but ML satisfies with less amount of data, but DL can deal with large amount of data. More the data, more the good accuracy with the DL, but ML couldn't able to provide that much good accuracy with the large amount of data. So at that moment, DL wins. Okay, so whatever the algorithm that we have seen over here, okay, you can impute in ML, but what happens with DL? Okay, if we are imputing the feature selection part in a DL, what will happen? So I need to give one simple tip that we can do it. Like what happens in actual DL? So in DL you are having an input value. Okay, it will create a neuron. Okay, you can take any network, ANN, CNN, RNN. Okay, okay, you are having one network. I think we can take it with ANN. It's so simple with, and then after you will be getting an output. Okay, so it just connect with it. Okay, it just connected, and then after you will be getting the output, right? For each and every iteration it goes over here and it calculates the output. So then it measures the error. Okay, if error is more than this point, then again it will take the backtracking method, and again the weight will be updated, and again this process continues unless the error is quite less, right? So the feature is selected within this neuron calculation, within a weight. So if for example this neuron is not at all imported, because of this neuron it's creating an error, or this neuron is not at all needed, then automatically the weight will be decreased. So if the weight will decrease, like if for example m1x1 we used to calculate, right, to calculate the slope, so what it will take, so if the m1 is decreased to 0.0001 into x1, whatever the value, so automatically it has the less weight. It means it automatically says that that features is not at all important, so it will directly drop out. So there is some dropout method also. If the feature is not at all important, it will directly drop out. So I can say from this feature this weight decreases, okay, at every iteration. So it and decreases, and it lies close to 0.01, so automatically it will be getting dropout. So the feature is selected within that neural network. But in ML it doesn't happen, we need to use the feature selection part. So in the SK library we are having some of the input feature selection process, like we have seen the decision tree. It's input, it's already has it. So by using that we can do it. But in deep learning it's also has itself feature selection part, everything, that whether if the weight decreases, then we can see that feature is not at all important, that's why it's decreasing on every iteration, and then after it will drop out that features also. So this is how the feature selection part is used in ML and DL. I hope this video find it out so useful. Please do like, share, and subscribe to this data discovery channel, and I will be coming across more related to data science part, data analysis, etc. things.